All right, welcome back to the last lesson for Unit 6. And we're going to be looking at the last form of a linear equation. And actually, there are two forms we are going to be looking at. They are quite similar, but a little different. Okay, so they are the general and the standard form. Okay, so let's do a quick review. Here is the graph, and we want to come up with the equation of this line in the slope-intercept form and the slope-point form. Okay, so for the slope-intercept, well, actually for both forms, the first step we need to do is to come up with a slope. Okay, so I can find two good points on this graph. Here's one here, and we should have another good point right here. Actually, the other good point should be right here, it looks like. Yeah, right here. Okay, so you can see the slope is rise over run, and we're going downward, so 1 2 2 down, so -2, and 1 2 3 to the right. Okay, so there is the slope. Now we know the slope-intercept form is equal to y equal to mx plus b. So m we already know is -2 over 3x plus the b value, which is the y-intercept of 4. Okay, now for the slope point form, it's very similar. I'm going to use this point right here, 3 comma 2. So it's going to be y minus y1, which in this case is a 2, equals m, which is the slope again, times x minus x1, which in this case is a 3. So there is the slope point form of this line. Okay, now again, you can use any point you want on the line. It doesn't really matter. Okay, so that's just a quick review. Here is the general form. It says general form of the equation of a linear function. It looks like this. Ax plus by plus c equal to 0. It says where a is a whole number and b and c are integers. Okay, so what that means is that the coefficients of a, b, and the constant c cannot be fractions, cannot be decimals. They all have to be integers, except that a has to be positive. Okay, so whole number and integer, the only difference is that a has to be positive. Okay, that's the difference between whole numbers and integers. Integers could be negative, but whole numbers must be positive. Okay, so a has to be positive, b and c could be negatives, but they all have to be non-fractions nor decimals. Okay, so for example, 3x plus 2y minus 5 equal to 0. This will be a general form. But -2x plus 4y plus 1 equal to 0 is not, because this is negative. So you need to make sure that x is positive. Okay, the coefficient of x is positive for it to be general form. Okay, so let's practice some questions here. It says write each equation in general form. You see that this is in slope-intercept form and this is in the slope point form. We are going to convert both into into general form. Okay, so the key is that we cannot have any fractions. So to get rid of fractions, what we can do is to multiply both sides by the denominator of 3. What that does is this 3 and the denominator of 3 will simply cancel out. However, you still need to multiply 3 with the rest of the terms, okay? So we're going to start with y times 3, which is 3y. -2 over 3 times 3 is -2. Again, that's the y we are multiplying by 3. So then this 3 and this 3 will just cancel out. Okay, we still have the x. And then 4 plus 4 times 3, which is 12. Okay, now you see we have no more fractions. Okay, now, so that's the first step, right? Get rid of the fraction. Secondly, you need to make sure that the term or the coefficient of x has to be positive, and that the rest of you got to move everything to one side and make the other side 0. So right now our x is negative. So to make it positive, we need to move everything on the right to the left. So we're going to plus 2x here and minus 12 here. Plus 2x here and then minus 12 here. So everything combined together on the left, you'll get 2x plus 3y minus 12. And once you move those two terms to the left, then you have nothing left on the right, and therefore equals 0. And that is the general form. Okay, notice how it's positive a, right? Okay, now that's how you do it for slope-intercept form. For slope point form, it's actually quite similar. Notice how we have the fraction right here. Again, we need to get rid of that fraction. by multiplying the entire thing by 5. Okay, so the left-hand side is the same, right? You just multiply y by 5, so 5y minus 1 times 5 is 5. We have 3/5 times 5, which is going to be 3. Be careful, okay? This is the common mistake. You do not multiply the x plus 2 by 5 as well. You only multiply 3 over 5 by 5. And what's the reason? Okay, well, if let's say we have 2 times 3 times 5. You don't actually multiply 5 with a 2 and with a 3. You only multiply 5 with 2 once, right? Because this really is the same as 2 times 3, which is 6, times 5, and that's 30. If you multiply the 5 with both 2 and 3, then you end up with 2 times 5, which is 6, and then 5 times 3 is 15, and that gives you 150. Okay, that's not the same as 30, right? So you don't actually distribute because there's no addition or subtraction sign. It's just multiplication. So you only multiply by once. Okay, so you only multiply 3 over 5 with 5, but not x plus 2. Okay, and now we can distribute. Okay, now we can distribute. Okay, so I'm going to keep the left-hand side the same for now. I'm going to distribute here. The reason why we need to distribute here is because, again, there is the plus sign here. So we now need to multiply the x and the 2 by 3. Okay, if this was 2x, then we don't, right? We don't distribute. Okay, so 3 times x is 3x, 3 times 2 is 6. Again, the goal is to make x positive. So right now, x is positive on the right. That means I'm going to move everything to the right. So minus 5y here, plus 5, minus 5y here, and plus 5. Therefore, the left-hand side will be 0. And on the right-hand side, I have the 3x still. I have the minus 5y, and 6 plus 5 is 11. And there is your general form. Okay, it doesn't matter if it's 0 equals or it equals to 0, right? As long as one side is equal to 0, then we're good. All right, if you have no questions, there are 2 practice questions for you to try. Okay, good luck, and I'll show you the answer in a bit. Okay, so here, similarly, times it by 4, right? So you get 4y equals negative 1x plus 3. Moving negative 1x to the left, you get x plus 4y. Move the positive 3 to the left, you get minus 3. And that is your general form. Okay, for the second one, you are going to multiply the whole thing by 2. So you have 2y plus 4 equals 3 over 2 times 2 is just a 3. Again, you don't multiply the bracket with the 2 out there. But now you need to multiply the bracket with 3 to expand it. Okay, so 2y plus 4 equals 3x minus 12. Our x is positive on the right, so I'm going to keep it there by moving the rest of the terms to the right. So 3x, 2y, move it to the right, becomes negative 2y. Plus 4 on the left, move it to the right means minus 4, so you get minus 16. Negative 12 minus 4 is negative 16. And there's your general form. Okay. So that's converting between the slope-point form and slope-intercept form to general form. Now, of course, when we have an equation, we need to know how to graph it, right? So now, how do we know if we have slope-point form? We have the slope and we have a point, we can graph. If we have a slope-intercept form, we have the y-intercept and we have the slope, we can graph, right? No problem. But this really doesn't tell us anything, okay? So what we can do is we can find the x and y-intercept quite easily. Or of course, you can also convert that into slope-intercept form. Okay, so it's always doable to convert into slope-intercept form. It's not as easy to convert into slope point, but slope-intercept form is definitely doable, and I'll show you how to do that in a second. But let's convert this into, or actually let's find the x and y-intercepts. To find x-intercept, recall, you make x 0, okay? You make y 0 and solve for x. And solve for x. So I'm going to have 3x plus 2 times 0 minus 18 equal to 0. So that gives me 3x minus 18 equal to 0. Then I can move the negative 18 to the right. And I can solve for x by dividing both sides by 3. Or, yeah, that's right, by 3. So then x equal to 6. So that is your x-intercept. For y-intercept, it's similar. Okay, what we do is you make, instead of y0, you now make x0. And then you solve for y. Okay, so it's just the opposite. Okay, so for y-intercept, you make x 0. For x-intercept, you make y 0. And the reason why we do that is because for x-intercept, it occurs on the x-axis. And all the y values on x-axis would have y value of 0. And that's why if you make y 0, that will tell you what the x-intercept is. Similarly, to find out what the y-intercept, because y-intercept, the y-intercept lies on the y-axis, so the x value of any point on the y-axis will be 0, and that's why you make x 0. Okay, so if you do that, you go 3 times 0 plus 2y minus 18 equal to 0. 3 times 0 is just 0, so you have 2y minus 18 equal to 0. Move 18 to the right, you get 2y equals 18. Divide both sides by 2, you get y equals to 9. Okay, so we have x-intercept of 6. So 1, 2, 3, 4, 5, 6. You have the y-intercept of 9. So what I'm going to do is because I don't actually have enough room, I'm going to scale this so that each line is worth 2. So 2, 4, 6, 8, that's 10. So 9 will be halfway through or halfway between 8 and 9. And then I can, let me just say that's 1, 2, 3, 4, 5, 6. So now I can connect the points, and there is my graph. Okay, so actually to graph a line in general form is not too bad. You just need to find the x and y intercepts. Okay, so there's the practice question for you to try. Good luck. Okay, so same thing, to find the x-intercept, you make y 0. So x plus 3 times 0 plus 9 equal to 0. X plus 9 equal to 0. So x is negative 9. That's your x-intercept. For y-intercept, you make x 0. So 0 plus 3 times 3y plus 9 equal to 0. So that's 3y plus 9 equal to 0. Moving 9 to the right, you get negative 9 here. Divide both sides by 3. Y equals negative 3. So my y-intercept is right here. My x-intercept is negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are your 2 points, and that is all you need to make a line. Okay, preferably you use a ruler to join the points to make it a straight line. Okay, so that's how you graph in general form. Okay, that's not too bad. Finally, or actually not finally, the next example, we want to figure out the slope of the line. Right? So this is when you need to convert this equation in general form into slope-intercept form. Recall, slope-intercept form is simply y equals mx plus b. So what we have to do from here is, as long as we can isolate for y, then we will get our mx plus b. Okay, so the goal is to isolate for y. Now, if I want to isolate for y, that means I need to keep y by itself, right? I need to keep y on one side and move the rest to the other side. So right now, my y is, actually everything is on the left. So I am just going to move this to the right. So, then I can keep the rest on the left. But then you can see y is now not quite by itself yet because there's a 2 still. But I can easily get rid of the 2 by dividing everything by 2, right? So if I divide everything by 2 here, divide everything by 2 here, you get 3 over 2x. Okay, 3 over 2 is, 1.5. It's not that bad, but we can leave it as a fraction. 16 over 2 is 8, right? 16 divided by 2 is 8. And 2y over 2 is just y. So the slope is 3 over 2. Right? And the y-intercept is negative 8. See, it's not that bad, right? It's not that bad. Okay, I just realized that these 2 questions are the same, so you don't need to do that one, but you can definitely try part B. Okay, so again, the goal is to find the slope, and therefore you need to isolate for y. So I'm going to move 2y to the right, and that will make it negative 2y here. Now you just need to divide everything by negative 2 to get rid of the negative 2 in front of the y, the coefficient. 4 divided by negative 2 is negative 2x. Negative 12 divided by negative 2 is positive 6. And that gives you positive y, so the slope is negative 2. That is your answer. Not too bad, right? Hopefully this is not too difficult for you. Sometimes it takes practice though, right? So if you're finding this a little bit challenging because it is a lot of algebra, you just isolating for y, you're moving things around. If you do enough practice, you'll get good at it, okay? All right, the last example I need to show you is to have a word problem here. So we're gonna come up with an equation from a graph of generated data. Okay, so here it says cashews cost $2 per 100 grams and raisins cost $1 per 100 grams. Devin has $10 to purchase both items, so he has in total $10. Generate some data for this relation. Okay, so the easiest way to do this is, well, what if I'm buying 0 grams of cashews? Well, in that case, how many grams of raisins can I get? Well, for raisins, it costs $1 for every 100 grams. Well, because I have $10, so then that means I can buy 10 times that, right? I can buy, because each dollar I can buy 100 grams, so for $10 I can buy 1,000 grams. Okay. Similarly, if I make, the mass for raisin 0, okay, I'm not buying any raisins. How much cashews can I get? Well, cashews cost $2 per 100 grams. So for $10, I can buy 5 times that amount, right? Because 2 times 5 is 10, right? So that means I can buy 5 times this amount. Well, 100 times 5 is 500 grams. So I can buy 500 grams of cashews if I don't get any raisins. Okay, so now, how do I come up with the equation here? Now, it says we want to write an equation in standard form. Okay, so now we haven't talked about what standard form is, because remember, general form is ax plus by plus c equal to 0. Standard form is actually quite similar. Standard form is ax plus by equal to c. Okay, so simply you're moving this constant to the right. Okay, now this actually is quite useful for word problems. Okay, so for example here, well, cashews is $2 each, right? Not $2 each, $2 for every 100 grams. Okay, so $2 for p, that will be how many grams we are getting, right? So it's 2p, right? Here's the variable p. I don't know why we're using p here. We probably should use c. Okay, that's fine. Plus, well, for raisin, it's $1 each, so it's 1r. 2p plus 1r should equal to, well, in total, we have $10 to spend. So 2p plus 1r equals $10, right? This is $2 per 100 grams. P tells you how many grams. So if you look at the unit, unit analysis, dollar per grams times grams, what happened then is the grams cancels out and left you with money. And if you do the same thing here, dollars per gram times grams, they cancel out, that left you with money. So 2 amount added together should equal to our total amount of $10. And that's why this equation works. 2p plus 1r is equal to 10. Okay, so this is the equation in standard form. Okay, now we are going to graph this data. Here is P, here is R. When we buy 0 grams of cashews, we can actually get 1,000 grams of raisin. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, not quite enough. Let me make this 10 right here. So that will be 1,000 grams. So because I'm saying each box is worth 100. So 2, 3, 4, 500 here, and that'll be 900 here. So, oh, not there. So if I just extend this a little bit, here is 1,000. And if I buy 500 grams of cashews, 1, 2, 3, 4, 5, here's 500. Here's 100. Each box is worth 100. Then I can only buy 0 grams of raisins. So there is our, okay, now my question is, should we join the points? The answer is yes, we can, because it's mass. Mass is continuous data. Okay, so we can safely join the points, and that is our graph. Okay, hopefully that is okay with you. There is one more question for you to try, and that would be it for this unit. Okay, we are wrapping it up. Okay, so give it a try. Good luck. Okay, so here we go. It says Jonathan is making a robotic car. He has 60 centimeters of copper wire that he will cut into 5 pieces with 2 different lengths. Okay, 2 pieces have the same length and the other 3 would also have the equal length. Okay, so let's say we have length of 2 same size pieces and we call that C, and the other one is length of 3 equal size pieces and we call that T. So you can actually do the same thing. I know we cannot cut 0 centimeters, but hypothetically speaking, let's say we cut 0 centimeter for the 2 same sizes, so 2 same size pieces. That means I still have to cut 3 parts, so then I can use up all the 60 centimeters of copper. Well, in that case, each piece will be 20 centimeter, right? 20 times 3 is 60. So assuming we have 0 for the, those 2 pieces, that's 0, then for the rest we have 20 each for those 3. And similarly, if for the 3 equal size pieces is 0, that means we need to cut this copper wire into 2 pieces of the same, which means each piece will be 30. Okay, now of course we cannot cut 0, for the size. So what we have to do when we graph this is, let me actually first do graphing first. So 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, and 30. This is our C, and this is T. So when C is 0, I can have 20. Now be careful, because this point doesn't actually happen, because you can't cut 0 centimeters. So that point should be an empty circle, okay? Empty circle, meaning that it doesn't actually touch that point. It's gonna get closer and closer to it, but it will never reach. Okay, so that's what it means to have a empty circle there. Similarly here, we should put 30, 0 in a empty circle. Okay, now because again the measurement here is centimeter, right? That's the variable, that's the unit. We can actually join them together because it's continuous data. So it will work for any points on that line except the endpoints, right? Because you can cut 0 centimeters. Okay, so for part C, write down an equation for the relation in standard form. So very similar, okay? It's going to be 2 times C plus 3 times T, and in total 60 centimeters of length, right? Because C is the length of each piece. So 2 times that will tell you the length for that portion. And 3 times T, well, we have 3 equal size pieces, and each piece is, has a length of T. So 3 times T will tell you how long those 3 pieces in total, in total. And therefore, if you combine them together, it will be 60 in total. And that is your equation right here. That is your equation in standard form. Okay, and that is it for this unit. There are some practice questions for you to do. If you have any questions, let me know. Otherwise, good luck with your questions.